Okay, hello all. It's gratitude to be rich. Always think about smiling. Okay, it's very important. Life is sweet. So in this our new video, we are going to talk about the pre-dimensioning of a beam. Okay, what we have to know is that we have two cases here. We have the beam are usually. Let me define pre-dimension. Pre-dimension is the process whereby you predetermine the dimension of a structural element. Okay, for example, a beam or a column or a footing even. Okay, now what is a beam? Since we are talking about beam, the pre-dimension is a beam. A beam is a horizontal structural element which is usually rectangular most of time, and then which is carrying half of the load of a slab. Okay, that's actually carrying the slab of a load. Okay, that's in the general case. Now here I've wrote it down already, the formula. So here you can see the formwork of a distribution plan or of a slab, okay, or if of a floor, showing already the repartition of the load here. So how do we pre-dimension an hollow block, an hollow slab? Okay, because here is an hollow slab, a one-way slab. Okay, so and how do we pre-dimension? We have three cases. We have the first case. Okay, the first case, to know, you have to find if your beam is more loaded. Second case, loaded or less loaded. So you have three type of beam: a loaded beam, a more loaded beam, a loaded beam, and a less loaded. Okay, so in the case of a more loaded beam, you have h, which is the depth of your beam. Okay, should be greater or equal than L on 10. Okay, in the case now of the loaded beam, okay, you have h which is greater than equal on L on 13. Okay, that's it. So in the third case now, less loaded, you have h which should be greater or equal than L on 15. What is L? L is simply the span of your beam, taken from the axis to axis. Okay, axis to axis. Okay, as you can see here. So what is, we don't forget the width of our beam. So because that's b annotate b, you have the depth and you have the width. So the formula to have the base now is 0.3 h less or equal than b, which should be less or equal than 0.7 h. Okay, these are formula used to determine the depth and the width. Okay, let's just start a brief example. Let's pre-dimension this beam b2. Okay, from the orientation of the load here, you can see how the load are being transferred. You can see that this is the orientation of our rebeam that will be sending the load to this. From for this slab, okay, they will be sending part of the load of this on this beam b2, and on this slab also they will be sending part of their load on this beam b2. As you can see, this arrow or this blue arrow showing that this beam b2 is working on the both side, so it's a more loaded beam. Okay, in this situation, b2 is a more loaded beam. So when the beam is receiving charge or load on from the two sides, it's a more loaded beam. So how do we get the depth of b2? B2 will have to take the span, which is 5 meter 20 or 520 centimeter, divide by 10, since we are in the first case of more loaded. So we divide the span by 10. 520 divided by 10 will give us 52. Okay, 52 centimeter, because this is in centimeter. Now we have h greater or equal than 52 centimeter from our condition. Okay, now for a matter of, let's say, implementation, and also to minimize the cost, the quantity estimate. Okay, for this special case, we decide instead to take something lower than h, which is 50 centimeter, which is more easy to put in place on chantier. And also because we have, in the pre-dimensioning, in the course of pre-dimensioning, we are trying to not over dimension. So we'll first of all use this 50 in our robot, for example, and if the 50 does not work, then now, or even calculating manually, if the 50 does not work, now we'll be able to go maybe to 55, for example. But we are trying to minimize and avoid over dimensioning. So b1, b2 here, okay, is something time 50 centimeter. Okay, this notation is actually because when you see like this, we always start by giving the width of the beam before giving the depth of the beam. So now we are going to look for B, the width of the beam or the base, which is using this formula. So using this formula, we are going to use 0.3 times 50, okay, which is giving us 15. We have 15, the base, and we have 0.7 times 50, which is giving 35. Okay, in this kind of situation, I usually advise to take the mean value. Okay, that's to sum the 35 plus 15 and divide by 2. It will divide, summing them, it will give 50, divide by 2, it will give us 25. So we just take the mean value 25. We will avoid to overestimate and also avoid to not estimate it well. So we'll take 25 in this case. Okay, now let's take another beam here. Let's pre-dimension, for example, beam B1. Okay, B1. Now we have to check also if B1 is more loaded or less loaded. From the direction of the arrow of the beam, actually we can realize that B1, this beam B1 is carrying half of this or half of the load of this slab. So by consequence, B1 is a loaded beam because there is no other slab on this way or other floor on this way. So B1 is just carrying the half of this load on this one side. It doesn't have load on both sides carrying. So it's a loaded beam. So we are in this second case. So to have the depth of B1, we will actually make 520 centimeter divided by 13. This case around we divide by 13 because B1 is just a loaded beam. So 520 divided by 13, we have 40. Okay, so it gives us 40 centimeter. Okay, now the condition said it should be h should be greater or equal than 40. So here we can directly take 40. It does not matter. Okay, so now let's try to get here. We can directly write it here 25 by 50. Sorry for the light, we have low voltage, so we have 40 here. Okay, I will come and put the B. So how do we get the base now? The base will be equal to 0.3 times 40, which is 12. Okay, less or equal than B, and 0.7 times 40 will give us 28. Okay, 28. Now we just sum the two, 12 plus 28. Okay, it will give us 40. As I told you, I usually take the mean value. You know already the reason. The mean value of 40 will be 20 in this case, so we'll have 20. So the beam B1 will be 20 by 40 beam. Okay, that's the pre-dimension of B1. So we are done with B1, B2. Okay, let's take now in this case B3, for example. B case B3, is it is it more loaded or less loaded? As you can see, we have this arrow showing the orientation of the ribbon or the transmission of the load. So they are showing here, the both of them are showing that this B3 is not carrying the load of this slab, and not also for this other slab. Okay, so it's not carrying this one and it's not carrying this one. So beam is B3, the beam B3 is just carrying the load of his self weight, and maybe for a wall, if there is a wall passing on top here, it will be carrying only a self weight and that wall. Okay, so B3 is that kind of beam that will actually qualify to be less loaded. Okay, this third case. So we have now, if we erase here, we take now the span of B3, of this B3, which is 2 meter, okay, or 200 centimeter. We divide by 15. I've already made the calculation once, so it will give us 13.33. You can check it with your calculator, 13.33. Now we know that h should be greater or equal than 13. Okay, 13.33. So for the course, for the sake of implementation, okay, and to respect also the condition, we will just take h to be equal than 15 centimeter. Okay, for this case, our B3 will be having a depth of 15 centimeter. Okay, 15 centimeter. Now we just find now the width of B3, okay, times 15. 0.3 times 15, it give us 4.5, less of equal, and here we do the same calculation, it will give us 10.5. okay, here now we know that B should be less of equal. Here we'll no more take the mean, because if we take 4.5 plus 10.5, it will give us 15 divided by 2. It will give us 7.5. And for the cost of implementation, okay, we'll try to take a digit that actually is easy to find as board, for example. So we'll just take directly base now equal to 10. So we just take 10 centimeter actually, and you see we are still in the range here. So that's it. We have pre-dimension B2, B3, B1. Now you know how to pre-dimension a beam. I hope you have learned something. If something is not clear, just leave it in comment, or you have to, if you want to help us to improve, you can leave us a comment. Okay, leave a like to encourage this channel, and if it's your first time, don't forget to subscribe to the channel. Okay, what is the importance of doing this pre-dimension? Is important because just realize that B2, for example, has a depth of 50. Okay, it has a depth of 50 centimeter. Imagine you transferring all this 50 centimeter on all this other beam, this one, even this one. Okay, 50 centimeter. Or we have just realized that this B3, its depth is 15 centimeter for this case. So you are adding 35 centimeter thickness of concrete, of reinforced concrete. Okay, that's concrete post reinforcement. Just imagine increasing 35 centimeter of thickness of concrete on all your beam, unnecessary, because this pre-dimension actually tell you that this is what can actually work for your structure. Your structure actually can work and can be stable, can be safe, functional with this dimension. So that's why it's very important to get to contact an expert for your work. Okay, it's very important. Contact, always get the mindset of an expert to make your calculation for you. An engineer, for example, like me, just contact me. Okay, avoid over estimating your cost estimate or your quantity estimate. So thank you very much. See you for our new video. Love you.